Okay, in this video we're going to talk about 5.5 and we're going to use inequalities in a triangle. So we have a little vocab to start with. So the first phrase that's in our vocab is the side opposite. So the side opposite is the side not adjacent. So right here you're going to see if you can squeeze in the word adjacent. Okay, so the side not adjacent to a given angle. So let's say, for example, if this is our angle, then the side opposite is this side because it's not adjacent, it's not touching that angle at all. Okay, an inequality is when there's a difference in either the length or the degree. So let me use this little triangle example again. So let me get rid of all of this, and we'll build another little triangle, and we'll talk about inequalities. So let's say I have this little triangle, and I tell you that this angle is 30, and that'll be angle A. And if this angle is, say, 40 degrees, I can say that angle A is not equal to angle C. That would be an inequality statement. I can also say that angle A is less than angle C. That's also an inequality statement. Or I could say that angle C is greater than angle A. All of those statements are inequality statements. We will usually in this section be working with the greater than or less than symbol. And just to refresh on that, if the symbol is going this direction, that means less than. This means greater than. Okay, let's go on now to the theorems in this section. So the first theorem we come to talks about the sides of a triangle. So it's called the sides of a triangle inequality theorem. So if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. Okay, so here we have a triangle. I have a length of AB equal to 8, a length of BC equal to 5. Okay, the angle opposite BC, so here's BC, its angle is angle A. That is opposite. Okay, I'm going to change color. And side length 8 is opposite angle C. Okay, it's opposite that. So let's go back to our theorem. If one side of a triangle is longer than another, okay, so the 8 is longer than the 5, then the angle opposite the longer side, so that is angle C, is larger. So let's change the symbol. So that angle C is larger than the shorter side. So that means angle C is larger or greater than angle A. All right, this is tied to our sides of a triangle inequality theorem. Okay, that brings us to our next theorem. So I'll change colors again. So our next theorem is the angles of a triangle inequality theorem. So I'm going to assume they're going to talk about angles here because in the sides of a triangle inequality theorem, we discussed sides. So here we go. If one angle of a triangle is, and you're going to fill in the word larger, is larger than another angle, then the side opposite the larger angle is longer or bigger than the side opposite the smaller angle. Okay, so we'll use some color again. So here is the smaller angle right here, and its side opposite is AB. All right? Here is the bigger angle, 50 degrees, and its side opposite is BC. So what can I say? So it says if one angle of a triangle is larger than the other, then the side opposite is longer than the side opposite the smaller angle. So I'm going to say which is the larger angle, and that's angle A. So side BC, so the BC length is going to be greater than the opposite of the 30-degree length, which is the AB length, and we'll do that again in orange. So BC is going to be greater than AB, and I know that because of the angles of a triangle inequality theorem. Okay, bigger angles give us bigger sides because the angle, as the angle opens up, it determines the size of the side opposite it. So the more an angle opens up, the bigger the side opposite it. So since the angle 50 degrees opens up wider than the angle 30 degrees, the side opposite the 50 has to be bigger than the side opposite the 30. Okay, let's go on to our last theorem in this section on the next slide. Okay, our last theorem, so this is the third theorem in this section, is the triangle inequality theorem. So we've done the side inequality theorem, we've done the angle inequality theorem, and now we're doing the triangle inequality theorem. Okay, so that theorem tells us that the sum, and this is our symbol for sum, okay, so this equals the word sum. So the sum of the length of any two sides, so any two sides of a triangle, is always greater than the length of the third side. So let me give these side lengths, or these side lengths some measurements. So let's make this an 8, we'll make this a 3, and this a 10, and so we'll check this theorem out. So they said any two added together. So let me add the 8 and the 3, and that has to be greater than 10. Is that true? Yes, because 8 and 3 are 11, and that's greater than 10. Okay, pick another two. How about if we say the 3 and the 10, that has to be greater than the 8. Is that true? So 3 plus 10 is 13, and that certainly is greater than 8. So far we are 2 for 2. Okay, so now we're going to add the 10 and the 8, and that has to be greater than the third side, which is a 3. So is that true? Well, 10 plus 8 is 18, and that is certainly greater than 3. So yes, so this theorem works. Okay, so we're going to apply this theorem and the other two theorems in the practice problems that follow next. So we have our three theorems. Let's go on to practice. All right, so let's read example 2. I'm not sure what happened in example 1, but we're on example 2, and it's the standardized test practice, which generally means it's going to be a multiple choice. So the example says you are constructing a stage prop that shows a large triangle mountain. So I outline the mountain for us. The bottom edge of the mountain is about 27 feet long. Okay, so this is about 27 feet long. the left slope is about 24. So here is our left slope. And the right slope is about 20. So we have all the sides of a triangle. You are told that one of the angles is about 46 degrees, I don't know which one, and one is about 59 degrees. I don't know what one. But then they say, what is the angle measure of the peak of the mountain? So they want this. So therefore, these two angle measurements must belong to the sides opposite the base angles. All right, so which one is which? So let's see. The 46 is smaller than the 59. So the 46 has to go with the smaller side. So here's my 20. 20 is smaller than 24. So therefore, opposite the 20 side must be the smaller of the two angles. So this has to be the 46. Opposite the 24 length side has to be the 59. So now the question is, what's the third remaining angle? So add these two guys together. That gives us 15, carry the 1, that's 105. How many degrees are in every single triangle? And you should be saying 180. So 180 minus the 105 gives me 75 degrees, and that is the measure of the peak angle. Okay, so we've used the fact that we know there's 180 degrees in a triangle, and we've also used the fact that the angles are tied into the side lengths. Big angles give us big side lengths, and smaller angles give us smaller side lengths. So we've used the theorem that we just learned a second ago in this problem, as well as an older one about the 180 degrees in a triangle. So let's go on to example 3 in the next slide. Okay, here's example 3, and it says find possible side lengths of a triangle. So they tell us that a triangle has one side length of 12 and another of 8. So let's draw a triangle and we'll label the sides. Okay, so here's a triangle. So it says one side length is 12 and another is 8. Describe the possible lengths of the third side. Okay, so this is about the third theorem that we just learned. So I know that there's a range of sides that is going to work for us. The way I determine that is the following. So this is the procedure. Write down your x, add the two sides that you've been given. So 12 and 8, that's 20. So the other side has to be less than that sum. So it has to be less than 20. Okay, what about the other way? So if you say it's less than 20, so say, for example, we could use 19, that works. That would make this the larger side. What if that missing side was the smaller side? How do I figure that out? So your procedure is this. You're going to say 12 minus 8, that's going to give us 4, and that missing side has to be greater than 4. Why is that the case? So let me erase the 19, and let's put the 4 in, saying that that's our smaller side. How does 4 work? Or does 4 work? So 4 is not going to work because why? Because 8 and 4 is 12. So the side has to be greater, 12 minus 8 is 4, and that's not going to work because the 8 and the 4 is equal to 12. 8 and something has to be greater than 12. So if this is like 4.1, that works. If it's 4.001, that works. If it's 4.000001, that works. So we say as long as x is greater than 4, we are good to go with our triangle. So what whole number values can you have? Well, you can have 5, 6, 7, 8, 9, 10, etc., all the way up to 19 for whole numbers that will work for this triangle side. So just to recap, when I want to figure out a missing side, it's not just one number that it's going to equal. It can be a range of numbers. And to do that range, put your x in the center, okay? Add the two sides they gave us, which was 12 and 8, and that gives us 20. That gives you what x has to be less than 20. So that's going to help you in a situation where the missing side is the largest side. If the missing side is the smallest side, subtract the two numbers you're given, and your x is going to be greater than that. As long as your x falls between 4 and 20, you will satisfy the requirements of a triangle. Okay, I'm going to erase this, and we're going to do one more just so you can have more practice on this. Okay, here's another practice problem. This is not in your notes, but I wanted to give you another little piece of practice on finding the missing side. So I want to find this missing side. So put your x in the middle, and then that x is going to be related to the missing sides, right? So it's going to be between two values. So if you add the 10 and the 6 together, you get 16. So when you add the two sides that you have been given, that sum has to be greater than the missing side. So since that sum is 16, that sum has to be greater than the missing side, so the missing side must be less than 16. That's where I'm getting this piece from. Now that's assuming that the missing side is the biggest side. What if it's the smallest side? To get that, subtract the two numbers you were given. You get a 4, and the missing side has to be greater than 4. So a whole number greater than 4 would be 5. 5 and 6 is greater than 10, so that works. 5 and 10 are greater than 6, so that works. So to get your range of side lengths, what you're going to do is add the two side lengths you've been given. That gives you your upper range. Subtract the two side lengths you were given. That gives you your lower range. So your x will be greater than, reading it this way, greater than 4, but less than 16. Okay, let's go on to the next page of notes. Okay, in this problem, for extra practice, they say 3 wooden beams will be nailed together to form a brace for a wall. And I've sketched in a little triangle for us. The bottom edge of the brace is about 8 feet. So this is about 8 feet across. And the side lengths are about 12 and 14 feet. One of the angle measures about 86 degrees, so I know one is 86, and the other measure about 35 degrees. Okay, so I have 2 of the angles. I don't know the third, so I need to figure that out first. So 6 and 5 is 11, carry the 1. 8 and 1 is 9, and 3 more makes, what does it make? Makes 12. So we have 121, right? So hold on a second. Yep, that's all good. So I'm still looking for the missing angle. So 180 minus 121 is 59 degrees. So now I have all 3 angles. 86, 35, and 59. They want to know what's the angle measure opposite the largest side. Well, it has to be the largest angle. So between 59, 86, and 35, what's the largest angle? And that angle is 86. So if we're going to fill in the angles opposite the sides that are given, the smallest angle of 35 would go opposite the 8. So this would be 35. Okay, 59 is the middle sized angle. So the middle size side is the 12. Whoops, sorry. So this would be the 59 degrees. And then 14 is the largest side. Has to be opposite the largest angle, which answers our question. Okay, we'll do extra practice question number 2 on the next slide. Okay, so in this second extra practice problem, it says a triangle has one side of length 11, so let's make this 11, and one of length 6. Describe the possible lengths of the third side. So I want an inequality statement. So your third side will be called x. So put your x in the middle of your inequality statement. Add 6 and 11, you get 17. So that other side has to be less than that sum. So therefore it has to be less than 17. All right. Now if it's less than 17, so let's say it's 16, then that's going to be the larger side of the triangle. What if the missing side is the smallest side of the triangle? To get that value, subtract 6 from 11, and you get 5. So your missing side has to be greater than 5. So what if it's 6? Does that work? Well, 6 and 6 is 12, so that's greater than 11. That's good. 11 and 6 is 17. That's greater than 6. So yes, that's going to work. So here is your possible lengths. X has to be less than 17, but greater than 5. So numbers between 5 and 17, not inclusive, is what's going to cover our length possibilities. Okay, so again, to get those numbers, I added the two numbers I was given. That gives me the upper range, and then I subtracted them. That gives me the lower. So x has to be less than the upper and greater than the lower, and that will build a nice triangle for me. So this ends the notes. You should be able to do the homework, which is the practice problems that you have in the end of your packet.